Welcome, everybody. The list of attendees is still growing, which is fine. I think we can get started anyway. You will have the opportunity to ask questions. I would even probably encourage during the talk as we are going forward. And I will try to keep an eye on that. Sometimes it's not so easy because I have two screens here. And yeah, I will try to have a look always, try to see if there's anybody raising their fingers or asking questions, vice versa. Right. We are going to be doing some hands-on ArangoDB cluster stuff generally. I'm going to explain a little bit how it works, what it consists of, and have my short list of stuff that I would like to go through. And hopefully I'm able to get through with everything that I have here. There will be definitely some sort of a document with all the commands that I run, the stuff that I've done, so that you guys have an opportunity to effectively replay this at home. Yeah, let's get started. So just generally speaking, I have the website open to our documentation. There is a neat picture down here that I would like to start off with, kind of explain what the cluster consists of and how the individual programs, instances work together to give you the impression of a cluster that is really, in terms of complexity, hidden from users. Yeah, so my screen is not shared. I'm getting some input. Let me do that. Share the screen. All right. Okay, so the ArangoDB cluster consists of the agency, coordinators, and DB servers. So the agency is effectively the configuration, the central hub, the animal brain, whatever you want to call it. Effectively, it's holding the entire configuration of the cluster. Every other service within the cluster depends on the agency pretty much to 100%. There are safety reasons for that, data safety reasons for that. Effectively, no service should do anything within the cluster if the agency cannot be reached. So any coordinator, any DB server will immediately cease operation for as long as it cannot talk to the agency. The agency itself consists of a bunch of ArangoDB instances. Each one of them is effectively a database server. They interact with the Raft consensus protocol. There is another talk that I put up about half a year ago. We will put the reference of that in the document that you can download for this meetup later, where I explained a little bit how the agency's internal functioning is working for the cluster. The Raft consensus protocol requires that if we look at this picture, of these three agents, at least two are up and running and communicating. Just being up and running will not be enough. They have to be able to communicate what we call a replicated log and a state machine that is then provided to the coordinators and to the DB servers. Within this state machine, we have the entire configuration of the cluster. So the first initial start of the cluster, when you were firing up with empty database directories and such, needs to bootstrap the cluster within the agency, one of the coordinators, the fastest one, will get a foot in the door and start doing the bootstrapping, stopping any other coordinators from doing so at the same time. Now, if the coordinator that was doing the bootstrapping should die during that process, it shouldn't be a great deal. It hopefully will recover later, whatever reason, if it was in a network split or if the server crashed or whatever it was, while the coordinator couldn't finish its job, some other coordinator will 60 seconds down the road pick up that work, assuming that something happened, and then do the bootstrapping going forward. Once the cluster is bootstrapped, you can always restart it much quicker than initially, because then the initial creation of the local database files and so on doesn't need to be repeated. Agents and DB servers. Let's not mix up stuff. The DB servers are the home to the database's data. So the user data that is stored in the database server in the cluster is distributed among these database servers. The way it is distributed is up to you. As the user, you can decide to replicate a collection. You can decide to shard the collection among different DB servers. This is all up to you. There are good reasons to do a single shard and a single replica. Just think of data that is negligible over a reboot, session data, whatever you could come up with that is not necessary for the operation after the next reboot. This kind of data doesn't need to go over the trouble of replication, go over the work that is involved in doing the sharding and all that stuff. So this can be done. But generally, one would like to think of collections that are created within the ArangoDB data cluster as sharded collections and as replicated collections. The sharding effectively distributes your data evenly, hopefully. You can decide a little bit on how that is done yourself. It doesn't have to be distributed equally, but it does make a lot of sense when you think of performance. So the job of the sharding is to distribute the data and allow you to have a lot more write I/O and a lot more read I/O than you would get from a single such machine that you used for the cluster. Obviously, if you have a ginormous, expensive single machine with a lot of fail safety, you could run a very decent and safe ArangoDB instance, but the cluster gives you the same kind of feel in terms of performance, but additional safety in terms of data security and fail safety and so on, resilience. And we will touch upon that a little later. We will go through this killing process. We will go through a rolling upgrade and stuff like that, that you couldn't obviously do with a single instance of ArangoDB. Okay, so the DB servers and the agents, they have some kind of a stored data locally that is, or somewhere on the network, that it needs to be recovered for after every reboot. That means that they need to have persistent storage that needs to be there at the next start, obviously, to be able to serve that data. Coordinators are different. Coordinators are the front end of the cluster. They offer the access to your cluster's database, and they offer you the Fox microservices that we have as a comparable mechanism, as you know it from SQL servers that stored procedures will do. Fox is, you can write Fox apps in JavaScript, effectively Node, and they are resilient across coordinators if you deploy them in a cluster, which means that even if one of your coordinators goes down, if you have load balancing set up that where you get redirected to some other coordinator, you are able to continue serving your application in towards your customers or whatever it is that you do with the database. Right. This is just the general setup. Obviously, the network between these machines needs to be there and operational. And as I said earlier, database servers and coordinators need at all times to be able to communicate with the agency. And the agency is only able to communicate with anybody out there if at least the majority of the agent is running and communicating and have established the Raft consensus protocol. For anybody who would like to have a little more insight into Raft, you can have a very nice and very good introduction into Raft on the website of the creators. It's on Raft GitHub.io. There is the original publication. There is a beautiful tool where you can play a little bit of Raft on that web interface, and it should pretty much answer all your questions with respect to Raft. All right, let's start by just deploying a cluster. I'm going to do this on 3 different machines. I set up a cluster on AWS for this purpose, but really everything will do. You could have your own bare metal in your rack, in your machine room. You could even start a cluster on a single machine to do staging and evaluation of the cluster and how it performs and how it works and so on. And obviously you can then deploy it on any kind of infrastructure like AWS, Google Cloud, and vice versa. I will briefly touch upon the Kubernetes operator that my colleague Ebert Pranksma has been the main author of, and we will definitely have another introduction specifically into the Kubernetes operation with ArangoDB, because there is a horde of stuff that you can do there that are really exciting, like real-time scaling of the cluster, so that you can, for example, suffice demands of additional coordinators during rush hours or vice versa. Right. There are the communication between the cluster nodes. Let's go back to that picture. Can be done both in on a secure channel via SSL, as well as secured by a JWT token when you have the authentication turned on in the cluster. I think that every decent service out there that is seriously operating ArangoDB as a cluster will employ both, be both SSL secured and have user administration turned on, so that even if you can access the coordinators, you can't mess with the data without obviously having the rights to do so. Right. What else should I mention just up front before I get started? Well, let's just do it and then we will find out. This was just the anatomy for you so that you have an idea of what the internal structure of the cluster is. Okay, I have here 3 machines. I've been calling them A1, A2, and A3. I'm going to just start here. I have installed, this is Ubuntu 16.04 LTS. I have installed ArangoDB 3.3.5 on all 3 machines. Let me show you briefly maybe, so this is pretty much, for example, the Kubernetes flow. I have every command that I have that I've run in installing the individual stuff that we need for the operation, be it JWT for Node or the ArangoDB software itself, I have already installed. So those stuff will be in the document that you get. You can rely upon that. So you don't need to be afraid that you won't be able to reproduce this yourself. So I'm going to start up with a bootstrapping of empty directories. As you can see, there is no data anywhere to be seen here. I don't need to stress the fact that obviously this data is important. I mean, yes, we have a lot of resilience on board, but still, I think one of the major jobs of a DB administrator would be to guard these database directories as crown jewels. The startup of the cluster is really easy. I'm just going to run this command. It's created 3 directories and it's sitting there here. So for one agent, one DB server, one coordinator, this is like the standard bootstrap of an ArangoDB cluster consisting of 3 agents, 3 coordinators, and 3 DB servers, each one on another machine, one set of coordinator, agent, and DB server on each machine. So this starter is sitting here and waiting for others to join it. And you can just use these command lines. I'm going to do it a little differently because I need to access, obviously, a different machine. In this case, this is A1 that we want to talk to, and we don't need this directory here. So I'm going to delete this. And the same we want to do over here. And once the third one is joined the party, you see a lot more happening on the command lines, and you will have to sit now and wait and watch and get yourself maybe a glass of water, which I should have actually. All right. When the system is done and up and ready, it offers you this one line. It says that your cluster is ready to access. Okay. This command is the command that you would run in your shell. So if I go over here, now this is my development computer, so I have to do stuff a little bit differently than you guys out there. I should be able to access that database, that cluster from here. Okay, if you have a close look at what you get to see when you run DB collections, if you're familiar with ArangoDB, this is giving you an overview of the collections that are there. You see that you have pretty much the same view that you would know from a single instance ArangoDB. However, all of these collections that you're seeing here are replicated without you noticing. As a matter of fact, I should be able to do something like this and you see that there is a replication factor here. This is something that you wouldn't see on a single instance. And there is no shards, although there is a shard key. So shard keys are something, I will touch upon that a little later, but shard keys are kind of an important and crucial concept here. Every collection that you create on a cluster with multiple shards needs to somehow decide how to distribute the data. And there is also some sort of mechanism when you want to go and access the data again to find out which DB server is hosting that particular document based on your query that is probably going to be based on that shard key. So the shard key is kind of a familiar concept, if you will, with what with a primary key, with a key in general, with a index in a sense. It is the most readily available kind of access to any kind of document that is anywhere in the cluster. So if a coordinator sees that you're looking for a particular user, it has a very straightforward way of knowing where to go to find that particular document. Doesn't have to hop around, ask all DB servers, and so on. This is a very performant way of accessing the data in the collection. Yeah, so what shall we start off with? Yeah, maybe we should also have a look at the UI. At the same time, I can also just punch in 8529. And we should get to see the front end of an ArangoDB cluster somewhere on AWS. This is all running over my wireless in the office. We have a not so great connection outside. It's fine, but it's not like the super ultra fastest. So this is might explain a little bit the lags that you're seeing here. But generally, if you're on a very strong line, if you have a good connection to your cloud or whatever, the whole process, the whole experience of dealing with the UI of a cluster comes very close to what you're used to when you're looking at a single instance around it. The difference is this dashboard here that is giving you some metrics on what you have in your cluster. You see that there are 3 coordinators and 3 DB servers, how much RAM you're using right now altogether, as kind of a rough estimate over all the machines. And yeah, you can also have a look at the nodes here. You see that we are using the internal network of AWS, obviously. The coordinators, their IP addresses, their ports, and vice versa. You can even actually click on a coordinators link and get some metrics, some information about obviously version number, the kind of software that you're running, and some performance metrics. Some of the stuff that I'm showing you here is documented well, others are not so documented, so well documented, but generally speaking, the UI, the dashboard, and so on, they kind of speak for themselves. If you take your time a little bit for 10 minutes or so and browse through all these pages, it should pretty much be clear what the individual stuff is supposed to tell you. If you go back to the nodes overview and do the same on a DB server, you see that DB servers, as they are not meant to be accessed directly from the outside, neither through an application, let alone a customer or a database user directly, they offer very limited information as far as compared to the coordinators. You see there is nothing to be seen here. But this is not a bug, it's just that DB servers and the metadata that is connected there is not really meant for front-end use. Right. You see we haven't created any collections besides the system collections that you saw. So these collections are never presented. These are pretty much the bare bone, the skeleton of any database in ArangoDB. In the backend, any of these collections is replicated or sharded somewhere on the cluster, and we don't know where exactly, but I will show you a couple of things in the agency that should clarify those questions. As a matter of fact, let's create now a database. We can do that through the shell or through the UI, obviously. Let's take the database foo and create it. This will take a little bit. What's happening in the back end is all the system collections that are necessary for this database foo are created. That's why it takes a little bit. And if you compare it to the experience that you have when you're on a single server, this took like a lot longer than it would take on a single server. This took somewhere in the order of 8 seconds when you compare it to a single server that does it pretty much instantaneously. This is really got to do with establishing of the replication protocol between every individual collection that was created. As a matter of fact, let's, for example, go and use that database that we just created. Then you will see that some stuff happened while I was talking. Again, you won't see these collections in the front end, even if we change into that database. And we go to the collections, there's nothing to be seen here. Let's create a collection that is not a system collection. Collection needs a name, and you can either create it like this. Let's actually do that and see what consequences this has. Go to the front end, it should pretty much appear any moment. I did change into this. Hello. Did I use the database? Yes, I did. Yeah, it's there. So where is it, friends? I'm just going to click back and forth. Refresh problem. Here is anyway our collection, and the collection's properties indicate that we have replication factor 1 and number of shards as 1. So just because you're creating collection in the cluster, it doesn't necessarily mean that you have clustered your collection. This is specifically designed to work like this. You might, as a user, want to create such collections, and again, there are good reasons. I mentioned a couple a little earlier. So if you want to create a collection that has that is profiting from being clustered, then we would have to create it a little differently. Let's drop this again and create it in a way that profits from being clustered. Number of shards, let's put that to 9. And let's set, oops, I don't need this. And replication factor 2. Right, okay. Let's go back here. Let's go to nodes, shards. Let's open this collection that we created. Okay, so our collection has been sharded in 9 individual buckets. These buckets, these shards, are local collections to DB servers. There is a leader to every shard. There is some kind of random algorithm that somehow distributes them. It's not a great algorithm, it does its purpose. It's distributed the shards kind of evenly among the DB servers 1, 2, 3. And also the followers to those shards have been kind of evenly distributed. I think it makes sense that I don't need to stress why it is like this, that you don't want to have this replica of a shard sitting on the same server as its leader. So there are a couple of things that you can do here. For example, you could move this shard to some other server, and as you can see, you can't move this here to the same DB server. And I think that I noticed this. I did this on purpose. I should have probably not done it. Yeah, it changed. Okay, this is a bug. I just found it live in front of you. Sorry for that. The reason why the shard was not moved to DB server 2 was that the leader is already sitting there. But the UI shouldn't allow you to do that anyway in the first place. So somehow this got broken somewhere down the road if I do it here. Okay, on the leaders, the bug doesn't exist. So if I wanted to move the leader of this shard to DB server 00, to any other DB server, the only one that is offered here in the dropdown is DB server 003. Let's do that too. So we are just moving the responsibility for this shard to another DB server, and that's it. All right. This takes a little bit, and this UI is not refreshed super often, because this is also stress that you're creating on the network and on your system. It just doesn't make sense to immediately go and check. But as you can see, the move happened, and we could shift a responsibility for a shard to a DB server of our choice. This is important. So just imagine that you wanted to manually clean everything that is on DB server 001 because you want to shut it down for maintenance reasons. It's probably a good idea to just get rid of the responsibilities of that DB server so that the internal mechanisms of the cluster don't have to do it. I mean, you could rely upon that, but it's just not a nice thing to do. Anyway, so you can see that the collection that we created with 9 shards and replication factor 2, if did exactly what as expected, it created 9 shards where every shard is replicated twice, randomly somehow distributed on any of 3 DB servers. All right, do we have any questions to this so far? I'm looking at the chat window, it's quiet. All right. All right, let's actually go ahead and play a little more with creation of collections. Let's create a collection. Yeah, maybe I should briefly talk about the number of shards. The replication factor, I think, is obvious. The replication factor, what it does is everything that you will insert in the collection will be replicated on the leader as well as on the amount of followers, whatever you set up. Obviously, you can, you have 3 DB servers, so you could go to replication factor 3 here. Let's do that also so that you have a visual comparison between the 2 collections. Anyway, so the number of shards is kind of a crucial concept, as I mentioned. This will pretty much dominate the way the data is distributed among your DB servers. And the reason why I set it way higher than the number of DB servers that I have is that I might be envisioning to move to 9 DB servers in a couple of months from now. Because I know this project is going to grow a little bit bigger than it is initially. I will get additional DB servers and attach them very much the same way that I added the servers so far, by just invoking the command with a join and on an additional DB server. What then happens is you will automatically get another coordinator and DB server. You can steer that a little bit, so you could just add coordinators. You could go ahead and just add DB servers. This is all. I'm here in the Arango shell. Let's go to a place where, let's open a new one. So the help shows you that you could, for example, say that you just wanted to add a DB server. I'm just not seeing it right here in front of me. Yeah, what am I missing here? Address, auto, threads, encryption, verbose. Yeah, here we go. So do you want to start an agent? Do you want to start an additional coordinator? Do you want to start an additional DB server, and so on? So this is flexible in that sense. So you could just add DB servers. Where significance of loaded, unloaded? You see on it. Okay, so every loaded collection, there is a question here in the chat. I forgot last time that I have actually to read them. So Santosh is asking, what is the significance of loaded and unloaded that we see on top of a collection name in the UI? So I don't know how you could spot that so quickly. Collections that are loaded are actually active and residing, if it's MM files, entirely in the RAM. The index is loaded so that this collection is really ready to serve. Whereas if you have the collection unloaded, it will not use any resources until such time that you actually access it, then it's loaded. But that would then mean an initial lag for that access. So that's just the difference. The loaded collections are ready to serve immediately. Any call that comes in that is reflecting, affecting those collections can be immediately answered. Whereas if you have, let's say, a collection that consists of a terabyte of data that would take some time to load, obviously, and be ready to serve. That's the difference in between loaded and unloaded. All right, let's go back to the UI. Let's click here. We have now 2 collections. This one has 3 shards, right? So we have 3 rows now. These are our shards, and they are sitting on the 3DB servers, and each one of the shards has 2 followers now, because we set the replication factor to 3. Okay, so the sharding is something that you cannot change down the road. If you wanted to change the sharding for the collection bus to match the number of DB servers that you are going to buy in a couple of months from now, you would have to actually export the data of bus, reshard the collection, effectively dropping it, creating it new with a proper setup that you want to have, and then re-import the data. So that's why lots of cases people would just create more shards than DB servers. And as a rough estimate, what we always, and this is like something that is empirical, something that we've seen our customers do a lot, we tend to set the number of shards to n squared. So in this case, we have 3 DB servers, number of DB servers squared. Then that would lead to the 9 that I came up with for the initial creation. So if I were, for example, as a database admin to create a collection that is supposed to cozily sit on this cluster and serve as best as it can, this is a meaningful setup. So you have the safety and you have the performance that you can gain from creating a collection in the cluster. Unfortunately, there is no way around thinking. I think every talk that I've given on anything that I've done so far in my life is that I would like to stress that just by putting something on a cluster, it doesn't speed up by the factor of the number of DB servers. The reasons are that, so if you have a very simple query that looks only for a particular attribute to get a couple of documents or 1 document out of a million documents that are distributed on your DB server, and your sharding key is the query key that you have, then this will give you the fastest access to data that you've seen so far. This will actually scale a lot if you're getting a lot of data, want to do some sorting, because the sorting can be pre-done on the DB servers so that the coordinators are just merging the data and serving it out. Anything that is more complicated than that will probably need some thinking in how you might even speed down your access, your read access, because aggregation of in your queries will obviously bring in complexity that needs to be at least thought about when beforehand. So your queries, you have to know your queries, you have to know the business model and the way you want to distribute the data, the queries, so that you have an understanding of how to distribute the data, maybe even over multiple collections to get you the performance that you would get from a cluster. So just to make one thing clear, obviously a single server with a single collection will easily outperform in terms of performance, read performance, a cluster when on the cluster you don't have multiple shards, but also just a single shard replicated maybe even 3 times for safety. That is, I think, obvious. This is noticeable, the speed difference, and you should keep that in mind when you're sitting there and you're surprised that something is slower suddenly that you went after you went to clustering your data. Oftentimes you have to restructure your searches. There are a couple of things that help you there. Let's go here to and put some data. Let's say in bar. Let's put a query here. Let's say insert. Say for I. Let's say 1000 or something. Insert I into baz and execute. Okay, we put just, this is not a very useful kind of collection. We just put in a lot of documents with an index and a number that are just growing. If you click here on explain, you get to see the computational complexity behind your query. On the right side, it's oftentimes, if it's not including any reads as you write, it's not very complicated to understand that there is how this works. So you have this is the query optimizer that's come up with this plan of how to put the stuff into the collection in your cluster. And if you go back and say, for example, say for I in, where did I put it, in bar, in bars, I think, return I and maybe filter something, say I is smaller than 200 or so, and click on explain. You see that this involves, let me just quickly look, that we don't have an index, for example, here. So we had to actually do a comparison of it. So we have to get every piece of data. This is a full collection scan that we have, and go through all of those and filter out those that are smaller than 200 and then collect them on the coordinator. If you execute this query, it takes 7 milliseconds, is not necessarily, oh, wait a sec. Yeah, I should have put in integers, right? Yeah, anyway, the point that I was going to make is, let's go back to the collection and create an index on it. On the field I, and if you go back to our query, you see that if I click on explain, for example, now, did it actually work? I have a filter on, this is on Baz, that I'm missing here right now. The index actually exists. Ah, it probably had to be created first. Simple expression let scatter distribute rule name filter is one. Okay, I don't know why this didn't work. Whatever, never mind. Anyway, so I just wanted to make you aware of the explain button. It will give you some hints on why stuff gets slower, what you have to maybe do to accelerate your query, and so on. All right. What else do I have here on my list? Yeah, so we created a database in the cluster. There's somebody who's giving me exactly what I need. Right, there we go. Thank you very much. Who was that? It was Doug. Very good. Thank you very much. Yeah, sometimes when you're doing something very, very simple and you don't see the error, that the problem that you have just freaks you out. Yeah, sorry for that. Thank you for helping me there. Yeah, okay. That was just a brief overview of what collections look like in the cluster and their internal anatomy of them. Again, just to give you an idea of what sharding and replication factor actually means and what the consequences might be. So let's talk about, let me see how, yeah, I need to speed up a little bit. Okay, let's look a little bit at stuff like resilience. Let's go back there and just turn off to DB servers. You see that we have here, where is my command on, say, DB2 or 3 or whatever. I'm just going to press Control-C here and stop agent, DB server, and coordinator on the cluster. We get an error message up here. You go back to the nodes overview, you see that we have 2 failing systems. Actually, there are 3. The agents we don't expose to the user. This is for a lot of reasons I can't go into too much, but just the idea that agents are not really something that users need to know of. This is a transparent kind of a configuration file, and you wouldn't put up a configuration file somewhere in this UI. It's just that agents don't really fit into this overview. It doesn't give you any additional insight in how you're dealing with your data, how your performance is working, how your Fox apps are stressing your coordinators. Agents are just a separate word. They are not shown here. But we can see that the agent is not there anymore by just looking at who is currently leading the, I think they are on 8531 in the agency. Config and JQ, at -y install JQ. JQ is just a beautifier, a pretty printer for JSON. Okay, what do we see here? This is the agency's configuration. Apparently, I did not kill the leader of the agency, otherwise the term of the agency would have changed from 1 to some higher number. The leader is AGNT DB323, and this is residing on, I don't know which one this is. This is possibly A1 is, actually I should be able to see that. A1, where is A1? Here we go. If config. This one has 104. So this one is still operational, and it's not the leader. So this guy here is the current leader, F5. And as a matter of fact, if I go and ask for this agent's configuration, there is a slight difference from what we see right now with this with agent 1. And that is, oops, refused. Why can't I access it? Why can't I access the agent? Is that the one that I killed? Sorry, that's the one that I killed. That's my own IP address, I guess. Let me just put in this IP address. No. Double colons. It's never going to work. Okay. As a matter of fact, let's go back and compare. So we have a last act object that is empty in the agent's configuration on server A1, and we have a last act that is populated on the agent that is currently leading the agency. You see also how many changes were made to your configuration in your cluster, but that's beside the point. You also see that one agent hasn't responded for a long period to queries coming from the leader. So you see that the agency remains operational. I can actually go and ask the agency here for some data by querying the slash directory in that agent, and it will serve me and inform me of some stuff. It will also show me that one coordinate has failed, one DB server is failed. Where is the DB server that's failed? It's up here. This DB server has failed, as you can see. And if you go back to the UI, we should see something rather interesting. Let's go to the shards of bar. Something happened to the shards on bar. So this is the resilient part of the cluster, of the ArangoDB cluster. There is not a single responsibility on any shard on DB server 0002, and there is no follower sitting on DB server 002. We have a green check at this collection because it is fully satisfying its replication factor, and in the back end, I can show you what happened. Maybe if I find it quickly, let's scroll up. There were a couple of things happening while I was speaking. After I killed the one coordinator, one DB server, and one agent. There are jobs that are finished that were effectively replacing responsibilities. In this case, moving a shard. The shard 4010.153, which is 4010.153. You should see it somewhere here. Is it the first one? Yeah. I need new glasses, I guess. So this shard had its leading shard sitting on this DB server. And this responsibility was moved to its follower, and subsequently, a new follower was attached to this shard. This is really nice. So as you can see, even if you wanted to, for example, replace hardware or something, you could effectively even just be very brutal about it and rely on the functionalities within the ArangoDB cluster to take care of that. Apparently, as you can see, there is no hope for shards that are replicated 3 times. So you see that it's sitting there as a follower in here, but the whole replication process has at least stopped for this follower, and this follower, while the leaders, probably even one of them was moved to a new server. So one of these shards was sitting definitely with its leader on DB server 002. That was taken care of. So you can actually still serve from a replication, from a collection where the replication factor is not satisfied anymore, but you will have this ugly warning here that something is not right. I'm going to go back now and just turn it back on. Where was I with the stopping of that particular process? Probably here. I'm just going to back in history and just run this again, and everything should come back up and be happy. And you see, this time it didn't take any time at all. It's already up and running, and the nodes went back to OK. This thing will finish off now, and everything's back to green. So in terms of resilience, that was an easy case. If I went ahead and killed at the same time, say, DB server 1 and DB server 3 now, that would definitely be the end for this, for the serving of this collection. This doesn't mean data loss, but it just means that every replica that you had of this one collection is now not available, so it cannot be served. This doesn't end the entire serving process. Every other collection will still be responsive. But if you don't have any of the data that was sitting in bar, obviously it's not going to be served. After these kind of events, it's a good idea to rebalance the shards. We have this neat button on the bottom right. If you click it, it will start doing some rebalancing, try to involve DB server 002 again a little bit. Right here it became a leader. When this finishes, we go to the next one. Here it becomes a follower. Let's wait and see what else is going to happen. Do we have anything else coming up? Yeah, there were actually a couple of things. So here, here, and here, and here, and here, we have DB server 00032 again involved in serving. Right. What else should I mention? There is an enterprise version of the cluster. Yeah, maybe something else that I should mention. If you are operating an ArangoDB cluster the way that I just started it like this, you don't want to, every time when you restart the server, to go and have to manually start these processes. You can set up a systemd script on systemd machines or an init script on upstart machines to do that job for you. It's actually another neat effect that the starter has, is that it monitors all the processes that it started. So if I go, for example, to the DB serve to this machine where we killed all the processes and just killed one of them, let's do that. Let's disconnect from here and go to A3. Here's grab Arangot and look for, let's say, the DB server, and just kill it. Which one would that be? This is this. Kill minus 15. The DB server is restarted automatically. So there is a mechanism that is monitoring the cluster's individual instances within the starter that restarts the processes again. This is a very nice feature that allows you to do rolling upgrades. And the way you would do rolling upgrades would be while the cluster is running, without having to stop any of these services right away, you would first upgrade ArangoDB software. And then once that is done, you would cycle through all your processes and kill them the way I just did, nicely with minus 15, with sig term effectively, and wait until it restarts. And after it's restarted, it's going to restart with a newer version of ArangoDB. So this is the way you would go through all these three machines, through all three processes, one after the other, wait until they're back, and then go on to the next one, until you've restarted all your processes, and then your upgrade is done and finished, and then you will see also on your coordinators front end the new version number. This is the same way you would, for example, be able to go back in version, for example. This is possible within minor versions. That is, I could go back to 3.3.4, but I can't go back to 3.2. Okay, you can't downgrade ArangoDB beyond minor numbers, minor revision. Only the patch levels are the ones that you can downgrade to. Yeah. Okay, so this was the rolling upgrade. This is the systemd script we will put in the package that we will give you completing this this talk. All right. I would like to mention a couple of additional things. This is the community edition that we were looking at. There is an enterprise edition, which is free for use, unlimited for unlimited time, and where you can implement stuff, try out stuff, go through the nice features that smart graphs and satellite collections and such have for speeding up queries in the cluster. There is a lot of stuff that we put in there that accelerates, for example, smart graphs would give you a much faster access to your to large, massive graphs. There are talks that you will find online if you look on YouTube for Michael Hackstein's talks about billion edges, handling billion edges in a database. They are very informative in terms of what are the consequences of going to a cluster and how to recover from that, from those consequences, and make the consequences actually to be beneficial for you. But again, this is something that is heavily still researched out there in the universities and a big deal. Another thing that you have if you have the enterprise version is, let me just go back to our website. This is the new feature that you have in ArangoDB version 3.3. We have a database, a data center to data center replication. That is the replication of clusters over distance anywhere in the world, which would allow you to have a backup or reserve cluster that doesn't have to have, by the way, the same architecture. That means that you don't have to have the same kind of hardware on the other side. Your number of DB servers doesn't have to match the one in one data center. And it's pretty much a replication on a higher level than that. That allows, for example, to have a backup on the cluster that is not, say, so super high-end like your first cluster that you have the big load on, but one that would allow you to switch then to the cluster that is still happy and living to run your operation, and then go fix the other cluster and switch back once you're done. So this is a very nice feature that's in the enterprise version. And I think that I would like to just mention a couple of final remarks. One thing is that we'd highly appreciate if you would star us on GitHub. This is something that I would love if you would take the time to go and do. And the other thing is that there's a meetup coming up. You find the ArangoDB meetup. This is next week, as far as I know. You find it on Meetup. If you're anywhere near Cologne and you would like to join us, free beer and pizza, you're welcome to join us. We will follow up in this cluster Meetup series with the consequences of and ideas of how to shard and how to really deploy real data. I get a message that the meetup is May. Anyway, you find it on meetup.com. So the meetup in Cologne is in May. And there's going to be a meetup following up that gives you the data side of things. So this was just the administration part, but also how do I do stuff in the cluster? How do I deploy real life applications into the cluster? Right. I would then take questions if there were any. Thank you. All right. Let me do one final thing, maybe. Let me go ahead and stop this guy again. This was the one that we earlier killed. This is DB server. Let's go back and see which one it is. So the numbering of the DB servers, by the way, that you see in the UI is not necessarily the same as you have on the outside. This is just some naming inside the ArangoDB system, and it's not reflective necessarily of the name outside. So this DB server 003 is not necessarily sitting on the server A3. There should be some stuff going on. I need to see which one was actually killed to do some stuff. I wanted to show you something. Okay, so A3 is obviously housing DB server 002. Okay, it's gone. It's for the one collection where we had only replication factor 2, everything is fine. We have responsibilities between 1 and 3 now. Let's go ahead and actually delete the data in here. Just radically delete it. Hello. Come on. Let's just delete the data and restart. There it is. Let's go back and see what happened. Okay, so you destroyed effectively your old DB server 002. It's completely gone. You don't have the data directory anymore. And everything is just lost that was sitting in there. But as you had, apparently you were so clever to do replication on enough machines so that failure of a single machine didn't create havoc for you. I clicked just now rebalance shard. The data was redistributed. We have now DB server 004 involved in both our collections. The one with replication factor 2, the one with replication factor 3. Let's go to the nodes and just get rid of this guy. It's never going to come back. It's just sitting there being red and ugly. And so as you can see, I can just throw away the database directories, and you could do the same to agents. For agents, there is a recovery ID parameter that needs to be specified on top. There is a documentation on that. Yeah, I think that's pretty much all I can show you with respect to the internals and the workings and mechanisms inside the cluster. There are no other questions as I can see while I was killing data. So with that, I would say then thanks everybody for listening, and hope to see you soon. Bye-bye. There's actually one question here. It's in a QA. It's by Anonymous. Does key and shard keys have to be used have to be coordinated in the same way? No, they don't have to. Shard keys and the key, so underscore key would be the default shard key. And it's always going to be a very performant way of accessing the data. But any shard key that you would add additionally to the to any collection will give you the same benefits. It has a very privileged and very quick access to the data. So no, they don't have to be coordinated in the same way. Okay, that's it. Bye-bye.